picking up good vibrations.
So now we're going to compute the Fourier transforms of given signals, and the one that we started with is the signal depicted here, which is 1 in the interval from minus capital T1 until capital T1, and it's 0 outside of this interval. Now, we have seen how to compute the Fourier series coefficients of the periodic replication of this signal, and we have called the envelope of those Fourier series coefficients the Fourier transform. We have already obtained a formula for that. So we should arrive at the exact same formula for that envelope by doing this, by computing now this Fourier transform. So this is a formula, this is the signal, so we just have to replace the signal here in the formula. If we do that, we notice that the signal is 0 outside of this interval from minus capital T1 until capital T1, so we can just replace the limits of integration by minus capital T1 till capital T1, and in that interval x of t is 1. So we can just say that the Fourier transform is the interval from minus capital T1 to capital T1 of 1 times e to the power of minus j omega t. Now, it's a complex exponential, but taking the primitive, we can compute integers pretty much as we compute in R, and we can in particular take the primitive of this and evaluate at the limits of the integration. And so the primitive is going to be 1 over minus j omega, and then we have to evaluate the function times e to the power of minus j omega t, and then we have to evaluate this function when t equals minus capital T1 and capital T1. So basically, if we evaluate it, it's going to give us e to the power of minus j omega capital T1 minus e to the power of minus j omega minus capital T1. So that minus, I'm going to evaluate first this one, and we're going to get e to the power of j omega T1 minus e to the power of minus j omega T1 over j omega. Now, I'm just simply going to use the fact that sine of omega T1 is nothing more than e to the power of j omega T1 minus e to the power of minus j omega T1 over 2j. So if I multiply by 2 here and by 2 here, I get 2 times, this is the sine, this is the sine, 2 times sine omega T1 over omega. And this is exactly the formula that we obtained for the envelope of the Fourier series. And so we arrive at the desired formula.